Recently, there have been a lot of videos that show what Gaussian splatting technology can do in creating scenes for visualization. Those typically involve cell phones that are recording video that go around an object with a couple of paths. I thought I'd check out here to see what Luma AI could do using their Gaussian splatting implementation to process imagery that was captured with a drone. So this is much different because the drone flies over a much larger area and has images taken from many different angles. It's not just taken on a simple linear path or circular path. Here we're navigating around the result you get, and it's incredibly easy on Luma AI to do we'll call it a reconstruction here, or a Gaussian splatting model of a scene. You just upload the photos and process it, and as long as you have images that are taken with a camera that is not a rectangular or a fisheye camera, it can go ahead at this point and do the image processing to create this model. This interactive model is really interesting and fun to fly around or to zoom around with your mouse and examine the scene, and it's pretty impressive what you can see, particularly on like the pipe structures at the end of that stadium. These are the drone photos that were captured. They were captured using software that flies a automatic flight path. 70% overlap was chosen. It flies in a lawn-mower type pattern, a crosshatch pattern in this case, back and forth, and then turns 90 degrees and then back and forth over the scene, and then flies a perimeter and takes a bunch of photos pointing back at the middle of the area. This gives an idea of what you could see in each individual photo, and that there's a lot of overlap between photos that's required for the processing. This is a visualization in Agisoft Metashape that shows the camera locations that were recovered in processing, and shows a textured model of the scene that was created. This is a virtual fly-through of that scene. It's very detailed, but things like the piping at the end of the stadium and the walls of the stadium don't show up well. Those are challenges for photogrammetric image processing that results from triangulation. This is a low angle here over these dirt piles. These are, if they were stock piles, would be interesting for construction folks, like to get volumes and things. That you can do from photogrammetry, where you have a meshed model and you can get elevation models and things, but you can't really do that directly from Gaussian splats. So there probably still will be quite a need for these models also for gaming and other things. Here's a close-up, kind of virtual flyby of me. I sat as still as I could during this capture that took about 7 minutes with the drone. I'm holding the drone remote in my hand here, although I'm a little bit blurry in things because the drone was up about 66 feet. It is interesting to see how well I turned out. This visualization shows, we're back to Luma AI here, and once the images are processed, you can go in and define a flight path. It's kind of a similar process to what I did in Agisoft Metashape that resulted in that virtual fly-through that we just saw, but this is a really nice interface they have for laying out keyframes and defining that flight path. The imagery that you see here, though, is not the Gaussian splatted version. It's a meshed model that is created for this kind of interactive visualization for defining that flight path. You can also then later do a rendering, which I'll show in a few minutes, of flying along that path that's computed offline and you can download. Here I'll play back now the scene within this flight path sort of editor, and this is that flight path that I had defined. So here we're flying through the scene. Again, it is the meshed model, not the Gaussian splatted version. So this is interesting because there's very different viewpoints than the original cameras are taken at. So Many of the scenes that I see online with circular paths taken with cell phones around an object, that object is very often viewed from similar viewpoints to the original photos. And the real challenge is when you create these scenes and viewpoints that are very different from where the original photos were captured. So this is a really rough model, but that's okay for using for this step of defining the flight path. It's interesting to note that the algorithms used in creating radiance field models using Gaussian splatting have a data constraint. There's an iterative processing of optimization that works to create the model such that it matches the images. And this overall approach is very different than what's done in traditional stereo photogrammetry. And this may lead to better models, and maybe in the future there'll even be some algorithms that combine photogrammetry and this model matching that create models that are even of higher quality. So next we're going to show the video that was rendered. It was rendered at 1080p quality. That processing to render it took, I don't know, a few minutes online or something, and then I downloaded that model that we'll see in just a moment. Here's that rendered video. So this is quite different than the last video that we saw that was through the flight path editor window when we played it back. This is actually using the Gaussian splatted model. That model shows pretty rough resolution, like over the gravel areas there, and shows sort of intermediate resolution at the piping at the edge of the playing field area here. It doesn't show as much detail certainly as the interactive portion, where the video that I showed at the beginning shows me just rotating around the scene. There you could see the actual Gaussian splats themselves. So I'm not sure what's different in the rendering here. I was really hoping that we would get similar quality here in this rendered video to the quality that we got as we perused the scene. Again, what was shown at the beginning of this video. So the quality of the model here, of the rendered video, is really quite poor as we zoom in close. When we zoom back out, pull back out, the quality just looks much better. And again, we're approaching here much more of the viewpoints where the cameras were when the photos were taken. So maybe the quality would be better if more Gaussians were used in the modeling process for imagery like this. It'll be interesting to see how that progresses through time as the technology and maybe devoted computing power towards this improves. Here's an individual scene, again just looking straight down, a comparison of the Gaussian splatting versus the photogrammetry, and both look quite good. Here's another scene more from a tilted or a off-nadir perspective, and the photogrammetry looks just much better, except for those areas of the piping on the netting at the ends of the field. Here we can see the field closer up, and again see the piping and the comparison there. The field texture is very different between the two models. And it's also interesting that the Luma AI has edges of the white area of the bounding box, and the Agisoft Metashape doesn't. Here's a close-up of me sitting on the rock, and you can see the Gaussian model itself on the left. This is from, again, the interactive viewing, not from the video itself. Here are the sort of stockpiles ground, and you can see there's just much more detail in the photogrammetry result than the Gaussian splatting result. Finally, here's what the car looks like. It'll be interesting to see how the technology and software improve for Gaussian splatting implementations over time. That's it. Thanks for watching.